Start? Okay. So hello everyone. Welcome to session one tutorial into R. So far we've opened up the R Studio here, and R Studio uses R essentially to come up with all the statistical analyses. It's just kind of helps us keep track of everything that's going on. It's kind of like our studio is kind of like an interface that helps R be more user friendly. And there's a couple things we're seeing here. We have our R console. This is sort of the output that you see on SPSS. This is sort of where things show up, and it's like a response. It kind of gives you a response of what's going on with every time you run an R code. Then we have our environment here. Any sort of data that we import will show up in here. Any kind of object we create in R will come up here. So what is that? What do I mean by an object in R? An object in R could be almost anything that's created in R. For instance, if I tell X that X is the mean of 50, then X will show up in my global environment and X will be an object. So X is essentially anything created in R using a function. Then here we have our files, so we're able to access documents and data that's on our computer. Then throughout the session, whenever we create a plot, um, it can show up here and you can export the image. And we have the packages section here. And I just want to say quickly a bit about what packages are. The way that R works is it's based off of several packages. It's very cool because this is sort of essentially why it allows why we allow R to be universal and why it's free. It's because several individuals from like all over the globe contribute statistical packages for several tasks. Like, for example, there's APA tables to create American Psychological Association style tables. There is CAR to create like companion to applied regression. Like there's a bunch of packages that do different things that many different people have came up with. And uh, essentially uh, the package base comes with R, like it's the R base package. But anytime you want to say you want to create something with APA tables, you have to make sure that that is turned on. And as what this means here, like as our console is our output, it means in our library, the system library, we've we've essentially turned on APA tables. We've loaded it. We've loaded this package in our library. So if we want to use any functions from APA tables, then it's turned on, something like that. And today we'll be using some packages that I will have to turn on, and we can see how that looks later. For instance, we'll be using a lot of ggplot. I'll just turn it on right now. I just want to show you a quick brief thing. So again, I've loaded ggplot, which helps us create visualizations. But if I press on this package, it gives you more information about ggplot2, and essentially like all the types of language it uses in its functions. Like these are very elaborate, and personally I don't necessarily know every single one either. But like it tells you any sort of code that could be associated with using the ggplot2 package, and like you can find out more information about it if you press on it. For instance, like for color, here it's color related aesthetics. This is like the color, the fill, and the alpha, and it gives you a description of what that actually means for the package of ggplot. So R looks pretty like elaborate and like confusing, but even like right now, this I bet like this doesn't look like the most I guess user friendly, like reading all of this, but as you get more used to it, it will be you'll see like after the learning curve, it's not so bad. So this was the packages section, and so some packages aren't listed in here. Like this is the last thing that's listed in my packages section, and for sure there's thousands of packages that exist. And what you would have to do to get access to those other packages is you would go on to install, and you would write the name of the package that you want to install in here, and it would show up into your system library. And then you can just load it anytime again without having to install it. So you can either, the same way I showed you, you can either just go into the packages, look it up, and turn it on to load it. Or you could actually also use our code to load packages. What that means is, as I said, this is just the console. So this is just like an output of what we've ran basically. But if I press this new file key icon, it allows me to decide like what other aspect of R do I want to use. So for instance, we'll be working with R script and R markdown. So R script will be sort of like syntax that you use in SPSS. So if I'm writing R code, I can use R script to run R code and just play around with the data. R markdown, I think R markdown is really cool because what you can do in R markdown is you can write a document that has your text associated with it. You have your code associated with it in there. You have your output of what your code generates. You can have it in there as well, and it can actually export it as a PDF or a Word document or an HTML file. So we'll be working with that as well. So it's really cool. For now, I'm just gonna create a new R script. This is how it looks when you first create the R script. And it's untitled. This is the save button. I find the find replace function quite handy, especially when you get used to R and how to use R. It's likely that you're not gonna have to like remember what code is what and what function is what. Usually people will tend to go back to code that they've used previously and just tweak that code to fit the new data. For instance, changing like the name of the variables, the name of the data file, and like minor changes, like say if you're making a graph or a plot, for instance, and last time your y-axis went up to 10, this time you wanted to make it up to 50. So people just tend to make like minor changes, and the find replace function will come very handy in doing that.
Sorry, Yekta, do you mind maximizing your RStudio screen a bit? Yeah,
Yes. Does this look
that
good?
helps to,
Perfect.
yes, a lot better.
Okay. And if you have any questions, please feel free to ask me whenever you would like. So what I want to show you is really quickly, I wanted to, where is it? The package called Psych.
I just had a question about the packages. Is there a certain package that is like most commonly used by, say, like, like maybe our lab? Is there something that is like default always used?
Mm, I guess the base R package is pretty much always used, and you actually like don't need to load it because it's always turned on. But um I think it really differs based on what you want to do. For instance, like if you want to get statistics, descriptive statistics, then you need to load different packages. If you need to do regressions, that's different packages usually. Like if you're trying to do t-tests, things like that. So it usually varies based on like topic, I want to say, because even visualizations have different packages. Um, so it does tend to vary quite a
And
lot. Yeah.
sorry, are you able to also combine like are you able to do descriptives and regression, like set both packages on and do it at the same time, sort of thing, or do you have to do every one separately?
Mhm. No, you can definitely have like I could turn on all of these packages, and I think that might make it very slow because like some packages tend to have the same function. For instance, I'm just gonna completely make this up, but Polycore and PPCore could both have in their packages something called mean. And then in that case, you would have to specify which package you want the mean function from. So that might be the only issue if you are turning on too many similar packages. But certainly like usually before you run any of your stats, you'll end up like loading all the packages that you're going to be using for that session, so they'll all be on
Okay,
together.
thank you.
Yeah. So for where were we? Yeah, psych package. So we're gonna be using the psych package today. It's one of the packages we'll be using. So I just wanted to show you like how you could run the R code. So library bracket is a function. This is how you would see it, like if you read about it online or like look it up, that's how it would come up, library bracket. But RStudio recognizes that it's a function. So, and it tells you which package, if I select this, for instance, which package it's going to come from, and it's coming from the base package. And it gives me like a quick um, outline of what it means. So here, for instance, it's telling me like what the setup should look like is once you type library, you should put in a package. And everything else here, we don't necessarily need to specify because these are like the default things that are turned on or the default setting of the library function. For instance, like I don't myself know what lib.loc is, but in the default setting, it's just null. And like character.only is false. So it's not looking at just characters. That I think that's what it might mean because it's saying it's false. If you ever wanted to change the default setting, you would have to specify it. For instance, I could put, these are all packages that show up from my library, everything that I have in here, but I'll put this in here. But if I ever wanted to change that default setting, like it was, I think it was like character dot only, and it gives me an explanation. It's like a logical, like it's like an argument that says that the package should be assumed to be a should be character strings. And we saw that that was false. So if I wanted to turn that on, I would just indicate like true, something like that. And I'm essentially changing the default settings, but we don't need to do that. And any kind of function has those sorts of default settings on or off. So I could turn, so I just ran this. What you could do if you have a Mac, you could just select it all and you could press your command and your return on your keyboard and it'll run it. Or you could also just press the run button here. And I received some feedback here that the package psych, it says that it's masked from the package ggplot2. So it seems like the package psych specifically, you can't always run it with ggplot2. It will turn on, but it seems like some things will be, like I said, similar as before, maybe like mean or whatever. I don't know in this case, because like ggplot is more about plots, but it seems like they're both share a similar function. And if that does happen, then you need to specify to R which one you're using. So we know that this, this command, so we're on line 1, was processed because this blue line is here, and it turned on in my library, and this is just telling me like some feedback. So you're always you sometimes don't get feedback, you sometimes do get feedback. If R doesn't run your command, it will try to give you an explanation as to why. Sometimes it can be pretty frustrating, but some other times it might be like, oh, you accidentally used too many brackets, or you placed the comma where you not a comma, but like an apostrophe where you shouldn't, things like that. So it will give you that explanation. And then we also have the help column here, which the cool thing about the help section is you can look up anything in the search section. For instance, if I search up like mean and like what mean is, it says that mean, if I were to put it like this, just like that, mean would show up from base, the base package, and it explains to me what it is. So, and also it tells me how to use it as well. So for instance, mean is for arithmetic mean. The description is that it's a generic function for the arithmetic mean or the trimmed arithmetic mean, and it tells me how to use it. It says that you should use it such that you write mean, and then in brackets you put an X followed by other things if you'd like. The default mode that's set up is like this, such that when you write what X is, trim is 0 and na.rm is false. So what does any of this really mean? X is just an object in R that you've created.
Like a variable?
It could be a variable, exactly. If I had, we'll see later when we import our data file,
Yeah.
that when we like want to take the mean of one of our variables, we would just indicate like, you know, data file, blah, 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 variable this mean, and it would do it for us because it just has to be any R object, so anything in our global environment that I guess anything in our global environment or like I guess oh well you can't really you could okay I'll show you so I'm getting too excited. uh, so that it just has to represent some sort of like numbers essentially like and it says that trim by default will be off because it'll just say 0 because if you by default you know people don't normally try to take like the trimmed mean but if you would like you know you could specify that you know you could write any fraction from 0 to 0.5 of the observations to be trimmed from each end of the x before the mean is calculated. So that's cool. And then na.rm, again, it's kind of just like a logical, I would say, like argument saying that any NA values, so missing values, should be stripped before the computation proceeds. And by default, it's just false, like it's just not on. And if you would like that, you would just change that, you would change the default setting and you would just indicate it and you would change it to true. So at the end, it gives you a really good explanation. And I'm gonna show you guys this example, but I also want to show you that people use R in very different ways. And it's just because there's so many possible ways of doing or using R that, you know, they're all correct. It's just more like, which one are you more comfortable with? So what I mean by that is, for instance, right now I want to show you an example of how this mean function was used. Can't zoom. Okay. Anyways, so the arrow suggests it's kind of like this is what this is. It's like we were trying to kind of communicate with R and using the code. We're trying to say the object X is created from this function. So anything before the arrow is the object, anything after the arrow is the function. So this object is made from this function, similar to this one. So this object here is made from this function.
Sorry, what is C?
Yes, I will get to it.
Okay.
So we want to say that X in this case, you know, it's made from, although this is all within a function, C bracket itself is also a function. So what C bracket does is it combines. So, and C bracket, does it show up? No. I wonder if I can. Okay, seems like I don't know what to search up here. I don't know specifically the name, but so it means combine, and we've kind of established what we wanted to combine in here. We could have asked it to just combine something like, in the most like simplest way, you'll see C bracket quite often. So that's just kind of why I wanted to go over it. Like I could in a very simple way, I could just say C 1, 2, 3. And this just like combines 1, 2, and 3. Like it uses 1, 2, and 3. You know, these are like the items. Sort of like think about it like as items it will be using. Like maybe observations in this case. And
Sorry, Yekta. So when you say combining, does it mean that you're adding like 1, 2, 3, or whatever numbers that you put in the bracket?
it sounds like you're adding it, but it's not really adding it. It's just kind of it's combining 3 items that consist of 1, 2, and 3 in this case. It's like it's like 3 single observations that are being used. So we're saying X, for instance, if we said, let's say Z, we're saying Z is a combination of 1, 2, and 3. And if we ran this, we get it in our global environment. We get the object Z, but it's something that is made up of 1, 2, 3.
Like you're parceling them, like
Yes,
you're boxing them into one box.
in a way, yes.
Okay.
And
Wow.
this in the global environment, the 1:3 shows you the number of observations you have or number of cases. So here it goes from 1 to 3. So there's 3 items.
Yeah.
So this is like the simplest way of using combine. You can just use commas.
Okay.
When you use the colon here, it means like 0 to 10, combining 0 to 10, as if you were to say 0, 1, 2, 3, so on and so forth until 10. And then combining that 50 times. So having 0 to 10 from 1, 2, 3, 4 until 10, that about 50 times. So if I were to run this, I would get my, it doesn't show you the rest, but I would have it in my R global environment. And now that I have it in my global environment, because X is now, I've established it as an object, I can do further functions. I can do further functions on X. For instance, it can be part of, it's kind of like cooking, I want to say, you know, when you just start off with your milk and then you add the sugar, you add cream, whatever. Well, that's baking, not cooking. But you're adding onto something that you've previously used or you've previously made. It's kind of like you're building from the bottom and you build as you go. So in the example provided, they wanted to say that XM is another function that they want to show up here because they want to use it later, for instance, but they want to say that they want to define XM as the mean of X. And because they have X previously, it works. Because if I were to run like mean of I, the letter I, like it would just, R would be like, I don't know what R is. Like, what is R? I mean, sorry, what is I? Like, what is it? You have to like really, it's kind of like there's a lot of communication going on. So if I'm going to run this, it tells me actually. So XM, because XM is the mean of X, it shows up as a number.
Which is the average of like 1 plus 2 plus 3 plus, right?
Yes.
Like up to 12.
Exactly. And then where was this? Okay, right. So then this is the final thing that they want to do. And it seems like, you know, they didn't associate this function with another object because like they just want to know what it is. They don't need to build off on it even more. So that's kind of how they like set up their example. So now the last thing that they want to do is they want to get an output that combines just the mean of X, but then the mean of X trimmed by what, 10% at each ends, I think 10%, yes. So if we run this, it doesn't show up in my global environment, but it shows up in my output.
Can you clarify on what trim means again? When you
Yes,
say
so
trimming a mean.
So we see that here it is. So we see that the function mean, if we don't turn on anything, if we don't edit the default settings, then it just does the mean. It just does the average. It just does the average, and it doesn't, if there's any missing values, it doesn't take them away, things like that. But if you want to change the settings, for instance, you can play around with the trim, because normally the trim would be just 0. You don't indicate it, but R knows that by default it's 0. But if you do indicate it, as they did here, then what trim does, it just takes a fraction of the observations and it trims it from each of the ends of X before the mean is computed. So
when would you need to trim a mean?
I think like we don't necessarily need to do that. I think it's just an option that's available, but also you might want to do that for bootstrapping, but I'm not sure if you would need that, but there are some things that, say if there's any outliers and you want the model of your data to be the mean, and maybe like a couple items are not representative and you're allowing yourself to trim the data to have a better mean, maybe that might be the case. People don't usually trim the mean. And also with bootstrapping, there's a different function that actually like bootstraps for you. So you don't really need, this isn't really need, I've never used it.
Okay.
But I'm kind of just using it as an example because I want to show you like that, there's default settings, but then you can also play around with that setting.
And a.rm, it just means that whether we want R to consider the missing values or to, strip them out.
Exactly.
Okay.
So because it's false, it means we wanted them to consider it. Yeah. So and if you play around with the default settings, like it shows that, very clearly your output will be different because, as I said, everyone plays around with R differently. And even though this was an object that they specified, and so was X, you could kind of sometimes, if it's not too complicated, you could have like, you could put, instead of putting like mean of X, they could have just used mean of C 0 to 10, 50 like this. And I would have gotten the same number. You don't necessarily need to create the X to represent what's in here. And I wonder if I can actually just do the rest too. I wonder if this is too many. It's maybe too many brackets. Let's see. 1, 2. Okay, I'm gonna run this and see what happens. Yeah, so it tells me that there's an extra bracket somewhere. It's this one. Okay, there we go. So it seems like I can't combine like too many things because I got a different output. But in this case where I just used Yeah, where in this case where I just did this, this was enough. I didn't have to necessarily make what's inside the brackets into X, you know? So what I'm trying to say is everyone can use X differently. If you wanted to make X an object, you could. If you're gonna do like several steps where you're using a certain like equation or a certain value or like a certain like complicated set of numbers, then it's better to create that object, because as you're going, you know, you can't always like put the specific thing that represents that object in your functions, because like I didn't get the same output. So it's sort of like make sure like if you're doing too many steps, then you clarify that. But even if you're not using that many, if I was to just stop here, I wouldn't have needed to create X, but it might just make it like easier, and it might make it just simpler and more clear if you do. Any questions?
Yeah, sorry. I did have a question about the combination thing you were talking about, like 0, 10, and like 50 observations or combinations or whatever. I'm not sure how like that translated to 1 12, like that ratio. I'm not sure what that like means.
Let me see. If we put like 3, let's see what differs. Whoops. If we put, let's do some experimentation and see what comes up. Okay. If we do 4, oops, not Z. Let's run this again. So what I did actually, I actually rewrote Z, so I need to make sure I use a different, let's do T, for instance. Okay. Oh, interesting. I'm not sure either. I will have to get back to you on that. That was weird.
Okay.
My apologies.
That's okay. Could you explain what it means though, like the combination thing? Like I didn't quite get. I get the 0 to 10 thing that kind of like sets the range, but I'm not sure like what the number after the comma is.
So yeah, like that's what is kind of showing up as, it seems like maybe it's not, maybe my understanding was different, that it's not like the number of times, but I remember I read that, but because it's computing the same thing, like T, X, and Z. If we like do T, X, and Z. So what I'm gonna do right now is I'm just gonna run my objects to see what comes up. Okay, so it gives you, I see. So the way that it seems like what I was trying to say, that it does it like 50 times, for instance, is not accurate. It seems like it's just changing the last item like after 0 to 10. That's weird though, but I read that somewhere. Maybe it was a different function. But the good thing is, at least like with R, you can always investigate. That's the cool thing. Such that, for instance, you know, like we're trying to figure out what the difference between these 3 is with X, Z, and T. And, you know, it's hard to kind of figure it out in here because I can't really expand it further than that. But because these are objects that I've created in my global environment, if I just run the object itself, it gives me, the output gives me a summary of what that object is. So to explain your, what this essentially means is combine 0 to 10 and this last digit. It seems like that's what it's doing. So that's why there's 12 observations or cases, because we have 0 and then we have this last digit as well, and it's just combining the 1 to 10 at the end as well. So does that make sense?
Yeah, that makes a bit more sense. Like there's that many like observations. So like I thought maybe adding like 50, like you know how we have 50 at the end, might be like saying, oh, but we're also adding, it's like 0 to 10, but we also add 50, like it's outside of the range. But then I guess we could do that with like 4 and 3 too, which is inside the range. So yeah,
It's
I
like,
didn't have time to do the supplementary reading either, so I'm not quite sure.
So yeah,
Okay.
what happens if you don't put the second number? Like if you only indicate the range?
it would only be up to that range. So to quickly like show you, it would just be up to 1 to 10, 0 to 10. So then I is a set of 11 observations. And if you just run the object itself, it explains to you what it is.
So I wonder if the number on the right, Raman, it's where when you have an outlier or something, or like when it's no longer sequential and you want to see, for instance, the first 10 observations, and then you also want to include like the 50th one or something.
Yeah, that's what I was thinking. So like when you say that you want to also include like the third or the fourth, does that double up that one? Like, do you see it twice?
Yeah, so it's 3 is right here, and then it also has 3 at the end. It's kind of like in addition to, as you said before.
Okay. Also, it says interval, maybe, I think, with I, but then T, X, and Z are like numerical or something. Like, is that what it means? Like,
I think it's because you know what?
Is it because you don't have C for the bracket to define I?
Oh, right. My bad. I forgot that. Yes. I'm gonna rewrite I by changing the function that explains I. So I just added C, and even though I have I in here as this, if I rewrite it by changing what I represents, it will also change in here. So if I rerun this, interesting, I don't know why that did not change. Interesting. I'm not sure why that one's interval and that one is numeric. Yes, I'm sorry I can't help much right now. I will find out for you.
it's okay, yeah.
I didn't expect so many questions. I've only taken one course. Please spare me. Okay. Any other questions that hopefully I can answer at this stage before we go on to import the data? No. Okay. So I'm sorry, but I will find out specifically what this is. Let me just take a note. Okay. Okay, so what I would, do you guys see this broom here? Yeah, so this broom just clears the console, and there's a broom up here too. I'm just gonna clear here as well. So everything's back to the way it was. And I recommend that, and I'm just gonna delete this too, don't save. And I recommend that anytime you want to start a new, you know, you want to start a whole new statistics work, you're working on something specific, and it's going to require you to use a lot of different like scripts. You're going to have a bunch of different like or markdowns. You're just going to have a bunch of tabs open, and you're using a data file associated with that. I recommend, instead of just like importing the data set in here, like you could do it from here's, or you could look it up in your computer. I recommend, instead of doing that, to create a new project. Don't save. And the reason why I suggest that, so this is just the name of my new project. The reason why I suggest creating a new project instead of just like importing things in and getting to work is because your project will save sort of everything that you were working with that was open in that project together, such that if you were to open up that project again, it'll open up the data file that you use, it'll open up the scripts that you use, it'll open up the R markdowns, anything, so you don't have to scramble and like look for them all over your computer, because like you're going to be importing a bunch of different data files, and you might be working with a lot of different things, and you might not remember where you placed them. So this is a good way of keeping track of all the sorts of different things that you will be using for your work. So I'm going to create the project. And I was working. So for instance, for example, I was working with this project before that project name, and it showed me like what the data file that it's not in here because I deleted it, but it brings it up. So this is proof that it saves aspects of what you're working with.
Sorry, how did you import it here again? I missed on that.
So what happened was, last night when I was making sure that everything works, I created a project called Session 1.
Okay.
And in Session 1, I imported a data file called income data. And because I saved it as a project, and because I like opened it up with the same name, it essentially used what was already saved and it opened it up again. So normally like you would just see nothing, like it would just look like this. But that only showed up because I already made a project before with that name. Yeah, so so it kind of shows you like how it works. If you create a project, it would just show, everything would just basically come back to where you left things off, and you don't have to load everything again. But I'm going to make it look like I had nothing in here. So I've created my project, and now I want to import my data file. So we're going to go into the data file, and I want to import, for instance, I want to import the income data. I'm just going to press it, and I'm going to say import data, and it gives me a preview. It gives me a data preview, and it also gives me the sort of like the address, sort of like the directory of where it could be accessed in my computer. So that will be important soon. And what I just want to note here is a couple things. The name of the data file will be very important because you will be consistently referring back to what the name is throughout your code. So I like to put something, that's not too difficult, not too vague, and something that I can like easily like work with, before. This is what it would look like before, there's 2 underscores, there's because R is case sensitive, you know, there's a capital I, there's a capital D, there's a number, you know, all these things, like, it could be time consuming, believe it or not, but when you need to change like so many little things and you need to keep typing that same name, it could be pretty annoying. So first I changed the data name because I wanted to show up as this in my R environment instead of as income data copy to. Then another thing I want to say is, because my data file was a CSV file, it automatically like knew how to organize it well. But sometimes certain files you would have to separate by like tab to create those nice columns. So just keep that in mind. And as you change it up, it gives you a preview. So this is not how we want our data to look. So we know we're okay with, you know, the comma. And this is just showing us the first 50 entries. So I am okay with how my data looks. I'm okay with my data name. And this is the code that will be processed when I import it. So my library will load the package read R, which basically reads data. My income data will become an object in my R environment that consists of opening a CSV file that has been derived from this address, and it's using the read_CSV function that I'm betting is from this package, and that's why they loaded it. And then the last thing is, it just says view income data, and that will show up in a tab. So when I import it, that's what happens. So now I have income data as an object in my environment because this code was ran. And then income data shows up because it says view income data. So we can again just look through, you know, we see the range, we see the way education is coded, all those sorts of things. Now I'm going to open a new R script. So this is where I can, you know, run some code and fun things. And as I said before, you know, we don't have to like remember specifically what each code necessarily means. We kind of have to just be familiar with the language, because if we're trying to understand something new, we just have to have enough understanding to be able to figure it out. And that's because people a lot of times will just use like R code that was made prior, that, you know, they just change various aspects of, as I said before, like they just change like the data name and like the variable, for instance. So I've just opened up, this is also an R script. It shows up as a new tab just because, you know, we'll be coming into it to select some things and pasting into that and changing up a few stuff. And then, do I need anything else?
Did we already select the package?
No, we didn't select. So you can actually look through your history as well to see here. Oh, this is my past history. I won't show you my past history when I created that project before. So based off of today, the only package that has been opened is this one.
And it came with the data, right?
Yeah, so that's because like I think read R is part of the base like the R base package knows to do this anytime a new data file is imported. It knows to first load read R and then open up that. So that's the only package that we've uploaded, and in an indirect way as well. So there were some questions that we wanted to answer, and I am going to also bring this template in here and show you the rest. So, okay. Oops. Okay, I'm just moving some Zoom stuff around. Okay. So as I said previously, R Markdown is something that you could, it's like it's another file you could create in R. And R Markdown, the cool thing is, if I were to make a new R Markdown file, you know, it asks me what I want the title to be. Whatever I place here will go in there. You know, I could be like introduction to descriptive statistics and visualizations, whatever. The author, whatever I place in here will go in there. And you can decide if you want it to be HTML, PDF, or Word.
So when do we need to do our Markdown?
It's if you want to export whatever you create into a document like a PDF or a Word document that contains not just the codes, but also the output, text, anything. So with, you know, your R code that's on an R script, I can't really export this as a PDF.
Right.
I can't really, like, if I'm to send it to someone else, I have to send it as an R code. They might not be able to open it, for instance, if they don't have R.
Right.
But
I see.
but yeah, exactly. So R Markdown, it has these like R chunks, like you can insert these like R chunks. And if you look, actually, like the icon is the same as the R script. It's because you can insert code in here and just run what's in that, versus like R code, all of this is just like this R script, this is all like a syntax file. Think of it like that. R Markdown can combine all the best parts of R together. So, and what you need to be cautious of is when you want to create this document, you need to make sure to feed R everything it needs. What do I mean by that? I mean, you need to make sure that you tell R what packages it needs to download to be able to export this document. Because whatever code I use here, if I, for example, use a function that's from the psych package, but I didn't tell this document, this markdown to, you know, install psych if it needs it, then my markdown is just not going to knit. That's what it's called. Like, you can knit it into a PDF, Word, whatever, but it's just not going to knit because it can't run certain functions just because we didn't specify it to, even if it's turned on in our library. So even if I have psych turned on in my library and I can run it in here, I'll be able to run it, you know, in these little R chunks, because R itself knows that it's on and it can turn and it can run it in these chunks. But to export it, it will need all of the packages listed here. And in addition to that, in addition to adding any required packages, you also need to add the code that tells you sort of the directory or like the address of where to access this income data. why, just like I said, you need to feed it everything it needs. You kind of have to pretend like it doesn't have access to anything we have access to, like our environment here, the packages that we have turned on here, all those things. And for that reason, we need to give it to it so that it can run everything else in our Markdown and then be able to export it. So you can access that directory when you first import your data file, because it will just show up in your output, and you can copy what's in here in there. Now, anything else I do, our Markdown will know which packages to use and which data file it will need, specifically for when I export it. Because if I didn't do any of these, I could still run everything because I have it all here. It just won't be able to knit in the end if I didn't specify it now, and it'll just give me an error. Any questions? No? Okay. So let's see. So what we were going to do today, so everyone seems like they've installed R. We've created a new R project, so showed you how to do that. We've created a new R syntax file. So just, these are just syntax files. These are just, the R scripts are like the R syntax files. Okay. The same way, like, as I said, because there are several ways of, what is it called? Because there are several ways of doing the same thing in R, the other thing I could have done is use the read.csv function here and just put income data, and it would have done the job of this. So that's just another thing I wanted to say, just because there's just a bunch of ways you can do the same thing. And then, okay, so now we want to calculate some things here. And it will require me to import a new data file as well. My second data file that I almost forgot about. And we will name it, what should we name it? I'm just gonna call it, this is hard, second data. I'm so bad with names. Wow. Second data. This is so bad. Yeah, sure. I guess so. So in this other second data file, I only have 10 observations and there's 3 variables. In my first one, I had 150. Where is it? Here. In this first one, I had 150 observations, again, of 3 variables. And I'm gonna just close these 2 because I don't like it when it gets too messy. But if I ever want to look back at it, I can just press this little chart here and it'll show up like that. So I'm not worried about that. But because I've, again, imported a new data file in here, before things get too messy, I'm just quickly gonna copy this and place it in here too. So that has everything in there. Now, the first thing that we want to do is we want to calculate the mean, median, standard deviation, min and max for these things using the base R functions. So I could just run it in the R script, I could go mean. So I'm using the base here. I could use, and we're using the second data, and we're looking at like pet spending or chair deaths, and we want to calculate the mean. So I'm gonna run it in script first and see how it looks. If I like it, I'm gonna copy the code, and then I'm gonna place it in my R chunk in my R Markdown because I want to export it later as a document. So I'll put the way that because I want to just look at pet spending, for instance, what I have to do is I have to specify which data I'm getting it from, and then I have to specify which variable. So how that works is, because we have everything in our global environment, we're able to use these names. I can say second data, it shows up itself. Then I need to use the $sign. $sign sort of means the variable associated with this data file. So when I put the $sign, it brings up some options, and I know I'm looking at pet spending. So if I run this, it will give me the mean. I could do the same thing for the second variable that I was looking at, which was chair deaths. And I could run this again. I can get the mean. And so right now I'm using, I haven't loaded any other packages because I'm using just the base R package. And I could look up the median as well. That is from, let's see, stats. Okay, I'm gonna see, pretty sure median should be in the base. No, I think this comes pre-installed then. Okay. Whoever has R open right now, could you let me know if your stats package is turned on without you having to have loaded it? I'm wondering if it's like natural, it's just like automatically on. I think it might be. But if you don't know, then that is completely
I can look. So okay, yeah. So the R stats package, it's automatically turned on.
Okay, perfect. So yeah, so it's also just part of the R. It's just and whatever is turned on, it just comes with R. Everything else you have to load. So that's why I can do median with the stats package, even though it's not base, but it's still just automatically always on. And then I can run these two. So I get the results here. And then I think I was also looking for the standard deviation, min and max. So I'm just gonna copy these and I'm gonna go standard deviation, min, max. So again, like so far I haven't, what is it called, loaded anything yet.
Is there a code that you can put in and it automatically gives you all the all the basic descriptives?
All of these, yes,
Okay.
but I'll give it to you guys, but because these are super simple, like nobody ever like puts these in anything, but it does get more complicated, and I do have that, but I also have these, so
Okay.
I'm just trying to kind of show you guys.
Sure.
So I think that was it all. Yeah. So I'm just gonna run it all, and like it seems pretty good to me, I think I put median 2 times for something, did I? So I have, okay, that's just new. Okay, I see. So it starts from here. Yeah. And yeah, so this is my output for what I've run here, and it looks pretty good to me. So I'm gonna copy it and I'm gonna put it in my R Markdown, just like that. And I can actually run just this chunk and it shows up like this, showing me like each one is associated with what. And when I actually export this as a document, this output will also show up too. So anything that you see here, the code, the text, and this output will all be on the document that you knit at the end. So that's the good thing. So we were just using like the corresponding like R functions, but now I want to show you guys how to find the descriptive statistics using the psych package called describe. And I'm going to copy the question in here so we can have it. Okay. So we want to, because we want to use describe, it's not usually turned on. So I'm going to have to turn on the psych package. And because we'll be using the psych package, I already have it in here, so that's great. But I don't think we have it turned on in this project. Do I have it turned on? I might have turned it. No, I don't have it turned on. So even though, you know, last time before I started this project, even though I turned it on before, it's not turned on now. That's because every time you need to turn on packages that you're going to be using, they always go back to the automatic, like the default settings that comes with R. So I'm not sure if you can change the default settings so that some of them are always on, but you would have to just turn those on. So I'm gonna insert another chunk. I am going to look in here. And so for descriptive statistics, I've placed, this is part of the summary that I've given you guys. And I guess I can put this in here and maybe send a new updated one. Using hashtag. If you ever want to write something, like if it's not code, if you want to use space and you don't want to get an error, you can use a hashtag at the beginning, because if you don't use a hashtag, and if I write the functions, it will give me an error. There we go. So you can just use a hashtag at the beginning so that error goes away. And then I'm just gonna save this. So, okay. Script is, okay. Okay, this. I am going to paste it in here. And so what this says here is, so we're using the psych package, and it's going to be using the describe function from the psych package, but we need to also load the psych package as we said before. So we'll just put psych. We will load this, and now it's turned on. Then we want to describe, I've put like chosen data name to represent the name of your data file in that R code for the various things that you could do. And in this case, we're looking at the second data, and we will run this. So this is what shows up. Before, you know, with the functions that we were using before, that's what like comes with R, but you can see how like tedious it can be when you have to do it every single time for every variable. But when you use, you know, the psych package to describe function, first of all, it does it for all the variables, and you don't have to run it, you know, like a bunch of times to get each individual statistic. You can just run one line of code and it gives it to you. It gives you the variable number that's associated with, like, this is the column that's associated with these variables. Like year is in column 1. There we go. So if you just hover over year, it tells you like column 1 for year and the range associated with it. And so same thing with the rest. So these numbers are just associated with the columns for each variable. It tells you the number of observations, the mean, standard deviation. And if I'm correct, like it's the same mean as before. Same standard deviation. Yes. And median, these two should be the same. Yes. Perfect. And it gives you like a trimmed version as well. I'm not sure specifically what fraction was trimmed. I would have to look. MAD was,
Sorry, the trimmed mean or the,
I believe so. I think
Okay.
it's the trimmed mean, but I'm not too sure. Like I haven't really like looked into that one,
sure.
and neither into the MAD. I think it's like mode. I'm not sure what MAD is. So, but like, again, if you look into like the psych package, specifically the function describe in help, it would tell you like what each and every thing in your output represents. But the good thing is, you know, it also gives you the skew and the kurtosis and standard error as well, if you wanted to make the confidence intervals, but you know, you're now getting some sort of idea of the distribution. So that's, you know, you're getting much more information. I would mostly just say, you know, say you're doing a bunch of stuff and you're too busy to look through a chunk of statistics here, and you just want to know one specific thing. Say you want to know the min of pet spend, the variable pet spending from this data. You could just quickly run this code instead of running psych describe the data file and then getting all of this. So, you know, there's benefits to both in my opinion, even though this one can be tedious if you want to get them all. I think it's just best to use the R-based functions when you're just mostly concerned with one aspect of the descriptive statistics, versus if you want to get the information for them all, you could use the describe function.
Is there a way for us to, you know, only do the descriptives for like a few variables out of the whole data set?
Yes, so you're
Yay.
getting to the next thing. So say like, you know, we just want to describe one of the variables. We don't want to describe them all. Let's say we were looking at pet spending. So we're looking at this data file and specifically pet spending. We just want to look at one variable. If we run this, we just get that. It doesn't say the variable name anymore. It just says x1. But, you know, this is all the same as in here. Yeah, so that's how you would get it for one variable specifically. And then I'm curious what.
How about more than one variables?
Sorry?
Like if I want to look at like for instance, out of this second data set, I only want to look at like 2 variables.
Okay, then you would put, I think it's a comma.
Yeah.
And then you would say like there were like 5 variables, but even though like we only have like 3, you know, out of the 3, we're interested in these 2, or like out of the 5, for instance. Chair deaths. If we're just interested in these 2, I think if you use a comma, it should, there were 11 warnings. Use brackets to see them. Interesting. Okay, unexpected. I think you might have to, you can't, and I think you might have to run it separately if that's the case. Can you do plus? I don't think you can do plus, but let's just try it. Can you? Oh, you know what plus does? It adds them together. Pretty sure, yeah. So yeah, you can't use plus. I think you would have to do it separately.
Okay.
If that's the case. So like you would just have to, they would be on 2 different lines, basically. You would run it like this, where this is the first variable,
Mhm.
and then this is the second variable.
Okay, got it.
Yeah, or maybe I just don't know. Maybe there is a way that I'm not familiar with. But yeah, from
That's
up
okay.
to my understanding. I'm curious to what this is. Okay, so interesting. If you just do a summary of your data, what it does is it gives you the quartiles, the min, the first quartile, the median, mean, third quartile, and the max, which can be useful, I guess, but for some people, like these, I guess we're not always interested about the quartiles. You could be, but that's what the summary does. It just gives you more information if you were interested in that. I mean, it's not stated in the other things that we did, so it could be useful too. I'm just going to copy this and place it in here. And I'm just gonna run it so you see what it looks like on here as well. It just looks like this. And there's an arrow so that you can go to the last column. Yeah. So that's what it looks like. Let's see what's next. Okay, so there's another package I want to show you for statistics. It's likely that there's other packages as well, but these are the ones that I'm most familiar with. And I don't think you should need any other ones if you're using this. Wonder if I have it in this barcode. Don't think so. Okay. So the other package that you can use is called the PastText package, and we could use the stat.desc function to compute the descriptive statistics. So I'm going to load that, and I'm just going to make sure that I have it in here. So I don't have PastText in here. I'll make sure I have to add that. So to add it. In the end, before I knit, I kind of want to show you guys what would happen if you accidentally missed adding a package in there. So you can see how that looks. So I'm going to run this. It just tells me that it's been done, and I'm sure it shows up on here as well. So you don't really need to check. I just want to show you guys, but and then we will be using the stat dot describe, and it shows us from the PastX package. And let's see if it runs. I just want to see if we can run the whole data file with just the data file and see if it does what the describe package did before. Yeah, so it would just give you 3 columns for your pet spending and chair. In that case, I am going to copy these.
Why is there like so many decimal places?
Yeah, so that's that's the thing about the PastX package with the stat.descriptives. It by default it has the the significant digits it uses is much more than the other packages, and you can change it. It's just by stat.describe. I wonder if it states it in here, but it gets pretty like tedious in my opinion. I like the stat function because it gives you some more information than the other two. I'll get to in a second. It doesn't tell you how to round it when you look it up on here, but there is a way that you can round like any output that I'm not too familiar with at the moment.
Okay.
But there is a way. I've never it hasn't bothered me enough yet to use it, but you can change any output to fit like 2 or 3 decimals. But when I send a follow-up email about the combined thing from before, why it was interval versus numeric, I will also share the code for how to round to a certain decimal place.
Okay, perfect.
Round to, okay. So this one has a lot more information than some of the others, but it's also missing some others. For instance, it doesn't have skew or kurtosis that described it. It didn't have that trimmed thing, but the other ones didn't, tell us if there's any like missing variables, if there's, these tells us like how many variables that it's using. So I think this is 10, if I'm correct. Yeah. It's just telling us like there's no null or missing variables. Then the cool thing I like about stat.describe is it gives you the standard error of the mean as the other did, but it also gives you the confidence interval of the mean for each. We don't really, and you can also like separate it by specific variable if this gets too messy and too cluttered. Also gives you the variance. I don't think the other one gave you the variance. No, so the other one didn't give you the variance. And it also gives you the coefficient of the variance. So the cool thing is with the other cool thing, I keep saying the cool thing. The other cool thing is with the stat.describe function, typically this is what the default setting is. For instance, for the confidence interval, it's using 95%. And for norm, it's false. And what is norm? Norm is actually, it runs a test of, it would run a Shapiro-Wilk test of normality if you turn it on. So it gives you an explanation of what or how it is, but typically norm is off. So what you could do is, let's just look at one variable so it's not too messy. And then go comma, we say norm, whoops, norm is equal to true. So, whoops, unused argument, interesting. Let's see if this changes. Oh, this is describe, my bad. We need stat.describe. Let's look at pet spending. Okay. So, okay. So if you turn on norm from false to true, in the other times that we ran this function, it was just false. That's why we didn't have to indicate anything, because by default it was just false. But because we wanted to change the default settings, we indicated that we want it to be true. And some new things that show up here are, it now gives you the skewness. It gives you, I think it's the 2 times. It's significant. That is, I don't know. I'm not too sure what skew.2se is. I think it's the 2 times standard error.
Sorry, where is skewness in this?
Right at the bottom.
Oh, okay. Okay, I didn't see the second row.
It tells you the skewness. I'm not sure what skew.2se is, and like, trust me, there's always gonna be things that like the output gives you that you don't know, just because like you're not gonna be using everything on here. Like, you're not necessarily like interested. So you don't get discouraged if you don't like know, and you can always look it up. So, but it gives you the test of normality, Shapiro-Wilk, the test statistic. So this is what the test statistic is. And then it also gives you the p-value that's associated with that. So it should tell you here, the statistic of a Shapiro-Wilk test of normality will be this one. And its associated probability will be this one. So these two. So that's something cool that you could get from just doing that, from the stat.describe. Now, again, as I've said, there's a million ways of doing the same thing in R. So I could actually just, if I just wanted to do a Shapiro-Wilk test, there's a function actually that does that, that only focuses on that. And
so Yukta, before we go there, so just going back to the table, so it shows that, so if the p-value it's non-significant, it's basically telling us that the distribution of your data set, it's not statistically significant. Well, it's not statistically it's not significantly different from a normal distribution.
yes.
Okay, got it.
So it is normally distributed, but we can't accept that. We can just fail to reject that it's
okay.
But yes, you're correct. So like I said, you might not be necessarily like, you might not want all this information. You might just want to do a Shapiro-Wilk test, and you could do that like this. And it uses a different function, It's called the Shapiro.test, and this is what the output looks like. It's much more simplified. It tells you where this information is coming from. It's from the second data file and the pet spending variable. It gives you the same test statistic and the same p-value associated with it. So it's honestly just like a preference of like what you like that matters. I'm just going to paste this in here. So I didn't do it for, I don't know, yeah, I didn't do it for both variables, but I think like you get the point. Plus Shapiro. Let me see. I don't want to take up too much time, but we're getting closer to the end. So the next thing I wanted to talk about was like the advantages and disadvantages of the three approaches that I've showed you to computing the descriptive statistics. So these included, you know, using the what comes with R, and then the psych describe, and using stat.desc. So, you know, this one, as I said, if you just are interested in one item, you could just quickly just look that one specific thing up. But if you want to do it for, if you're interested in information for all three variables and more than just one piece of information, it could be pretty tedious. For psych describe, you know, you might not be, since like I'm not sure how to show like the rounding it up to like to a certain significant digits, then appearance wise, like this might be more appealing to some individuals, for instance, like this. But at the moment, if you're looking for more information and you don't mind that your data could look like this, the stat.describe function is not a bad one either, because it also gives you information on the confidence intervals, and you could even run a test of normality here. And if you do that, it gives you information on the skewness and kurtosis, although it doesn't give it to you initially, unless if you specify. So if you want that extra information, you have to make sure that you've stated norm equals true in order to investigate those aspects of the distribution. So now we can look at, oops. Okay. Oh no, what is going on to my computer? Okay. Is my computer working on your end? Okay, there we go. Q dot, oops, question 4. So, okay. Let's insert our R chunk. And I'm also going to put question 5. And okay, I think that's good. Okay, so we want to look at creating the scatter plot using the plot function. So the plot function, we won't need to worry about uploading any packages, because I think that one is also just turned on. It uses graphics.
Jika, sorry.
Okay. So yeah, so the plot function, it uses graphics, and I'm sure that it's on already, yeah, as it's part of just the R graphics package. And we are interested in our X and Y variables, and we wanted to, how did we want to do this? We wanted to put pet spending on the x-axis and chair deaths on the y-axis. Weird names, I know. Blame my lab. So and it kind of gives you an idea of how to format it. So it just goes, you state what you want your X to be, and we said we wanted to be pet spending, but make sure like I used to do this so often, I would just, immediately like I put pet spending like this, but R won't recognize this, so you need to make sure you're always clarifying where you're getting your data from, and you might run into error and you're just like hating your life because you're like, you don't know what you did wrong, but it might just be the case that you just forgot to clarify where your data is coming from, and that's just the only reason why R is just not it's just not doing what you're asking it to. So for plot, it just said to state X and then to just state Y. And we do that, and a plot shows up right here.
This is a scatter plot?
Yes, it is. So it's just a scatter plot using the basic R package called plot. So, first time I saw this is just pretty exciting, but there are nicer ways of doing scatter plots. But this is just the most basic way of doing it. It can get pretty elaborate when you start using things like ggplot, which I have the code here for you. So we were interested in the scatter plots. Scatter. I swear I have it in here. So that's histograms. Interesting. Why didn't it find my scatter plot? Okay. So we could just go with this. Yeah, and then you could get very elaborate if you really want
Wow, simple scatter with regression line.
it. Yeah, it could get pretty elaborate. So basically, I'll give a quick explanation. So when you start to, again, get more complicated, it gets useful to start labeling things as an object that show up in your environment. So here, the setup will be different. With plot, it asks us to just go X, Y. With ggplot, come on, give us the info. Okay, so. Okay, with ggplot, it's a little bit more complicated than just X, Y. If you look up how the function ggplot is used, it goes the data file, the name, and then the EAS, I think it's called like some like aesthetics, other like the aesthetics, like I think it's like the things that are used in the graph. And that's where you would indicate the variables, your X and your Y. There are just other things that you can change as well. As we said, for instance, like if you want to change the default settings, like you could play around with the environment. Not specifically sure about how you could play around with the environment, but I'm sure that there are examples of how you could manipulate that. But for today, we will stick to a less intense version. And because hopefully I am right, but because we are already stating where our data is coming from, you could still, when you're writing your variable one, you could still go data file $ variable one, but I don't think you need to. Hopefully I'm right, because you've already stated where these variables are coming from, like such. I'm just gonna run this before we could not find right. So it tells me you could not find ggplot, and this is because I didn't run the package. ggplot. There we go. Okay. Okay, so this looks pretty, yes, weird. Where are all the dots? But don't worry. This is just creating like the groundwork for the scatter plot. So as I said before, though, because you've already stated where the data is coming from, you don't need to use the $ in here. So we're just going to create this object called scatter, and it just shows up here. And it gives you information about scatter and like where it came from, how it's made, what does it consist of, a bunch of stuff that like I don't necessarily understand everything about it, but yeah, it just has a lot of information that you could look into. And then we want to add points, obviously, to our scatter plot. And we also want to use like, we don't want it to say chair underscore deaths. We want it to say number of chair deaths, for example. So we go scatter plus GM points, and then we put the name of X, and X was pet spending. Yes, I have to move Zoom stuff around.
Right.
Pet spending. And whenever you see like the quotes, if there's like two of those dots, it means it's like it's specific in its like capitalization. It's like that specific thing will show up. It's usually like a title or like a name. Okay. There we go. So, this might look nicer than the previous plot did. But as I said, and like everything that I placed in there also shows up. And there's a cool thing that you could do instead of, exporting like this, instead of like saving this plot like this, you could just run this code here. Where you can save the image and you can indicate what you want the name to be by just, again, running this code instead of export whatever. And it would save it by the PNG extension, which suggests it would be saved as an image. I bet you could change it to PDF ending so that it exports it as a PDF. I just wanted to add that. So
Biekta, is there any way to change the scaling on the table? Like right now, I see that on the y-axis, it starts at 160 and the x-axis starts at 40.
Yes, so good question. There is a way, think, let me see, it might be in here. Yes, there is a way. I've done it before.
Okay.
You have to like adjust the width, I think is what it's called. It seems like I don't have the R code right now. I can get you that R code too.
Sure. If you could add it on your list.
Do you have any other questions? No? Okay, perfect. So yeah, so I'm just going to copy this and place it in here. It's almost 2, or sorry, it's almost 1. And I think we agreed on 12:30 to 1. I was hoping to get to the box plots and the histograms and the QQ plots, but I might have to hold off until next session. I don't want to keep you guys all waiting, but let me see if I'm just gonna show you guys how to knit this. I'm just gonna try to knit all of this and see what it looks like. But before we do that, I just want to show you that if you go into view, you can, is it view? I don't think it's, okay, it's actually, I found it. So you can press this in the corner and it kind of gives you an outline of what you have in your R Markdown. So if you just want to quickly jump to here or anywhere else. So the hashtags can be useful in kind of creating like sections. And also, you know, if your R Markdown is getting kind of crowded and you want to crunch things, you can press on these arrows and the lines 27 to 38, which contain that code, just become like shrunk in that section. But you can even like shrink the question itself too, like this. So I just wanted to say that, and you could even shrink this as well. So whenever there's like, wherever there's an arrow, you can just make it smaller instead of always having to scroll back and forth, up and down, and like trying to look for a section. You could use the this outline here, which could be useful. But we are going to try to knit, and hopefully it doesn't give us, oh look, an error. So it says we have an error. Okay, so this error, I don't think we used this data file today, so I'm just going to remove this. But this error is just it's just saying that it couldn't find read_CSV, and that's because it's supposed to be read.csv. I forgot to mention that. So hopefully this is fine now. So we're going to try to knit again. Hopefully we don't get any other, look, another error. So 57, it's saying could not find function save in image directory. So I'm going to guess this is because save in image directory is something that requires a package. Let's see which package it requires. Okay, it didn't show up there. Does it tell me? Which package does this need? Let's see if it runs here. Could not find saving. Okay, so yeah, it requires a package, but I'm not sure which package. So I'm just going to remove it because I don't really want this saved right now, but I will also get you the package. Save an image directory requires package for. And where it would save it is where you saved your project. So back in here, it would save it here actually, like that. So I'm gonna remove this and I think it should knit now. Okay, awesome. Let's see. Perfect. Okay, so I am going to bring this over. So this is what it looks like. So I didn't specify a title, but if I had, it would show up here, whatever my title was. the name I would have specified and the date. And this is how it doesn't show us this initial section because it just needs it for itself to be able to run everything. And it doesn't, this stuff doesn't show up, but it begins at question 1 and all the code that I have, and each code, the output associated with each code is directly underneath as such. And also, whenever I use a hashtag, it turns green. It will also show up in your output as well. So sometimes I like to leave notes near like the code that I run. For instance, if I'm like trying to remind myself why I used a certain thing, for example, stuff like that. So again, it gives you the output associated with each variable, and then output associated with each code as such. And so your plots will, I can't edit this right now because it shows up as a read-only file, but you just have to duplicate it and make a new one. Once you've duplicated it, your plots show up as images. So you can move it around like an image. You can copy this onto a new document. Same thing with this one. And yeah, I will send you guys a copy of my R Markdown, what I've saved here. And hope I can see if I can also send you my project. So but I think that might not work because if your files are in a different like directory, like address than mine are, it might not work for you. So the project might just work for me. So I'll send you guys the R Markdown, and I will send you the document that I also made, and anything else that I think might be important, along with those things that I need to find for you all. Any other questions? No? Perfect. Then I will stop sharing. I hope you all enjoyed, and I wish that I could get to the end, but you were all very enthusiastic.